This is question 5 from paper 1-3 from June 2020 by Cambridge International Education. In the description below the video, you'll find a link to an image of this question so you can try it before looking at my solutions. This question looks a little different than other ones. They're really just asking us one thing. It's a lot of English, so a lot of students do have some difficulty with it. What they're asking us is exactly what is the length from here all the way around to here. They're saying it's sort of like a bicycle chain. You could look at it like this, except there's often a smaller one down there. This would be a very common question as well they could ask. Basically this with two parts, two circles either side. So how long is this all the way around? They give us lots of information. From P to the center O is 13. It's a little unclear where is 13, not here, all the way to O. And then we have from here to here is 5. And I believe that's all. Yeah, that's all we need. Something we should know, but they do tell us in the question is that that's a right angle. That is a right angle. So we can get to work on this question. There's really two parts of it we need to look at. There's a arc that's part of a circle here. We need to know what the length of the circumference of this circle is. And they usually would need the angle here for that. And there's a formula for that. We'll come to that in a minute. Because the other part we need would be these triangles. If you don't see the triangles, have a little closer look. You need to find a triangle there. A right angle one is this. So it's 13 long. It's a right angle and it's 5. Now that's really good because if we get a triangle with 3 things we know, unless they're all 3 the same sides, all the 3 lengths, that's not as good. But 3 things we know, we can figure out absolutely anything you need on this triangle. And one thing we need is this length. So let's just find this length here. To do that, we're going to use Pythagoras' theorem. We have 5 squared, well, let's call this one x to help us out. We would get, well, let's write it this way. 13 squared must equal, the hypotenuse squared is equal to the sum of the other 2 sides. 5 squared plus x squared. Let's clean this up. We'll get 13 squared minus 5 squared is equal to x squared. Let's write that the other way around. X is equal to 13 squared minus 5 squared, and we'll square root it while we're here. Square root of that. You put this on a calculator, or I think it is easy enough to do. It's 169 minus 25, which is equal to, yes, it is an easy one, 144. Square root of 144 is 12. So we now know the length here is 12. That's a lot of our work done. 12 plus another 12. All we need to do is find the circumference of this circle. We have formulas for that. Let's see. Theta divided by 2 pi, that's how much of the circle I need, times the length of an entire circle is 2 pi r. So they cancel. So we're just left with the formula is just the angle times the radius. That's if this is in radians, by the way. Much simpler if it's in radians. If it's in degrees, we have another formula. It's very similar. I guess it's theta divided by 360. Because that's the only difference between radians and degrees. Theta divided 360 by 2 pi r. So yeah, well, that's the formula there. A good bit messier. I'll use this one here. So I'm going to make sure your calculator is in radians for this. So I really need this angle here. How do I get that? That's sort of the second tricky thing to do in this question. First thing to notice is, if I can't get that, how about finding this one here? It should be very similar. It should be just 2 pi minus theta. We'll get, or whichever way you want to go. I'll call this phi. I can't remember the name, the proper name for it. So how do I find this? Again, the thing to notice is that this cuts it in half. So this angle in here is half of it. This angle in here is half of it. And remember, I said, if we know 3 things, we now know 4. If we know 3 things about a triangle, we can find out everything. So I can find this angle in here, which will give me this whole angle, which will give me this whole angle, which will give me the answer I need. Okay, so let's go ahead and find this. Again, we just have a right angle triangle, so there's lots of rules. You can use sine of this sine of the angle is equal to this divided by this. That's 12 now. Or you can use cosine. Cosine of the angle is equal to 5 divided by 13. Either one you want. I'll go ahead and use sine of phi over 2 must equal 12. X is 12, remember, 12 divided by 13. So phi divided by 2 is equal to the inverse sine. Calculator will do that for you. 12 over 13. And phi is equal to 2 times this guy. Again, I like to leave it like this until later in the question, and I'll go ahead and use the calculator to find out what number this is. So that tells me this angle here. I want this angle. So theta is equal to 2 pi, the entire circle, minus this one. So minus 2 times sine minus 1, 12 over 13. And I simply want the length. So I want theta times r. That'll give me the length around here. So theta times r is equal to 2 pi r. That's quite interesting. That's the whole circle. Minus 2 sine, inverse sine, 12 over 13. Okay, I put all that into a calculator and I will get 19.7. So that again is the length from here all the way around to here. All I need to do then is add on 12 plus another 12. So my full answer, let's call the full answer P. P is equal to 19.7 plus 12 plus 12, which is 24. 24 plus mostly 20 is 44, but it was only mostly 20, so 43.7. Put that in a calculator. Don't do things like this in your head, I would recommend, unless you're really confident you're going to get them. I have done it before, so I have the answer written over there on a piece of paper, so I can see that I got it right. In an exam you won't, so double check on a calculator. But this is it. This is the final answer. This length plus this length plus this length. If you have any follow-up questions about any of that, especially maybe about radians and degrees, did you do it in degrees? You should get the same answer. It should be identical answer at this point. By the way, this is rounded off to 3 significant numbers. But you'll just get different answers in the middle. It will look a little different in the middle, but the end will be the same. I just use radians when I have a choice because it's a better unit to use than degrees. Okay, thanks for watching. Have a great day.